Chapter 6, First Order Differential Equations. These are the list of the topics to be covered in this chapter, which include the formations of differential equations, solutions of differential equations by direct integrations, solutions of differential equations by separating the variables, solutions of differentiations by substituting y equals to vx, and also solutions of differentiations equations by using an integrating factor. Without further ado, let us get started. First, we discuss about the formations of differential equations. The differential equations are those being differentiated from functions of y. These are typical differential equations. This is the first order differential equations, which is written as dy dx, and this is the second order differential equations, which is normally written in the form of d square y per dx square. These differential equations are normally obtained from a differentiation process. From a function y, if you differentiate to the first time, it becomes the first order differential equations, and if you differentiate to the second time, it will be the second order differential equations. Same goes to these functions. Solving the differential equations by using the direct integrations. The differential equations, which in the form of dy dx, can be solved through direct integrations. You learn about basis of the integrations in your chapter 3, as discussed in the previous videos. Without further ado, let us try some examples on this. These questions ask you to determine the general solutions for these functions. The general solution should look something like this, which is in the form of the functions of y. In order to determine the y out of the function here, you will need to integrate the functions. Write down the functions here. Rearrange the functions by moving the x to the other side. This gives you this. From the function here, you can actually separate them into two terms. This is so that later when you want to do the integrations, you can integrate them term by term. After you have separated them into the two terms, you may simplify this to become 4x squared. From the functions dy dx here, you need to integrate both sides in order for you to acquire y functions. Integrate this term by term, you will get this. And your final answer here will be the general solutions for this. Let us try another example on this. Given the differential functions here, and the boundary conditions given are y equals to 1, 2 per 5, and x equals to 2. This represents a non-coordinate on the functions. You are asked to find the solutions for the differential equations. That means we are looking at the functions of y. Given dy dx here, you will need to go through an integrations process in order for you to acquire y. Copy the function here. Rearrange the functions by moving the 5 to the opposite side and moving the 2x also to the opposite side. From the function here, you can separate them into two terms. It is so that you can integrate them separately. From the function here, you need to integrate them both sides in order for you to acquire the y. Integrate them separately and you will get your functions in the constant of c. It is given a coordinate which is on the functions, which is 2, 1, 2 per 5. Substitute the relevant value into the x and the y, which give you this. The only unknown now, it will be the c, which end up to be c equals to 1. Substitute back c equals to 1 into the integrated functions. You will get your final solutions to be this. Now let us try these examples on differential functions. The equations is given here, and it is given that theta is equals to 2 when t is equals to 1. By looking at the equation here, you will see a d theta dt. In order for you to solve this function, you will need to integrate the entire functions in order for you to obtain the function theta. With that, write down the functions and rearrange the functions so that you have d theta dt on one side while the others on the other side. Move the 2t to the opposite side, which will give you 5 per 2t. Swap the positions of d theta dt and 5 per 2t. That will give you this function. Integrate the entire functions over dt and you will obtain these equations, terms by term, plus c. You will need to determine the c. Based on the information given, which is theta equals to 2 when t is equals to 1, substitute 2 and 1 into the function here, and you are able to determine the c. Substitute the c back into the equation here, you will get this. Rearrange the functions, you will get the final answer.